All right, 1.6, solving absolute value inequalities. So we're going to put the last 2 days together. So some things that we would like to remember. When we multiply or divide by a negative, we got to flip the sign. Okay? We need to remember that for an and problem, we're thinking between. Our answer should be written with a number between the x's. The x is between the two numbers. If you put the small number on the left and the big number on the right, you will always use these less than signs. So that's the way most books do it. We remember that for an and graph, it usually looks like that. For an or, we want all possible solutions. We don't rewrite the way the answer looks. It's just going to be x is, let's say, less than 4 or x is greater than -2. It wouldn't make any difference. We just want to be or. Okay? And then typically our graph is the ends of the graph. Now that's not always true, just typically. Special cases. For an and, you might get no solution. For an or, you might get all reals. Meaning, when you graphed it, you colored the whole number line. So if I actually had graphed this one right here that I gave you, then the whole number line would have been shaded, so you would have written all reals underneath of it. If, for an and problem, you can't write it between, and it doesn't overlap this way, then it's going to be no solution. So those are just some basics to know before you start these. Now we need to remember we're back to absolute value problems. Absolute value problems, we had some steps to follow. The first step was to isolate. The second step was to check for a solution. The third step was to write two equations. The fourth step was to solve. And at this point, we're going to say solve and graph. So that's new. And then we'll have some other possibilities when we check for solutions now. So we'll talk about those as we get to them. When you're writing the equations, there's a couple of new things. So there's a lot of the same stuff that we've gone over, but we add to it. So let's get started. Number 1, 3c is greater than 15. Step 1, isolate. Already done. Step 2, check for a solution. Well, these are going to be positive numbers. Are they going to be greater than 15? Well, it's possible. It's possible to have a positive number greater than 15. So yeah, there's going to be some solutions. So we're ready to keep going. Writing our two equations. All right. Our first equation is 3c is greater than 15. Now, in all the problems we had done with equal to signs, we used the word or. Now we have to decide which word to use. And I'm going to use the word or in this problem because it's a greater than sign. So you may want to make yourself a note. If it's greater than, you're using or. If it's less than, you're using and. Now it doesn't matter if it has the equal to sign on it. It's the same as if it doesn't. The word is the same. So you might also want to put that when it's an equals problem, you also use the word or. That's what's going to determine which word. Okay, now we need to write our second equation. So we would say that 3c, and instead of just putting greater than, you have to switch it to less than. You also need to make it -15. So not only do we switch this sign to negative, we have to flip that inequality sign as well. Once you have it all set up, then you just solve it. So we're going to divide by +3. So it would be greater than 5, or c would be less than -5. So if we graph our solution, now it's an or problem, So we're thinking it's probably going to look like the ends of the graph. That would be perfect. Otherwise, we might get an all real. So we just graph it and see. Real simple graphs. 5 greater than is an open circle. And -5, open circle, less than. So what do you know? It looks like a typical OR problem. So you think you probably got it right. And that's all you do for an OR. So we'll move on down. It's an absolute value problem. We're going to set up two equations because it doesn't have a negative sign over here, so we know there's got to be some solutions. It's already isolated. So write your two equations. R plus 4 is less than or equal to 10. Is it an and or an or? Less than would be and. R plus 4 is greater than or equal to -10. So we make sure we make those switches. Notice in this line I don't have any absolute value signs, just like in the last section. Solve, so subtract 4. All right, it's an and problem. Anytime you have an and problem, you have to write it, or you try to write it, as an in-between problem. The smallest number needs to go on the left, so that would be -14, and the bigger number, 6, would go on the right. Now, is it pointing at the right stuff? Here we're pointing at the -14. Up here, good, we're pointing at the -14. Over here we're pointing away from the 6. Away from the 6. So that looks good to me. So now you have to graph that. And that graph would be between -14 and 6, including them. So we're going to use a colored in circle and shade between. Now some people like to do the graphing before this. If you do the graphing before this, you would have noticed if you did R is less than or equal to 6, you would have graphed this. And if you did R is greater than or equal to -14, you would have graphed this. And then the question would be, where do they overlap? That's what it means. Where do they overlap? Well, you can see they're overlapping right here in my dark green. So I think it's faster to do this red part, write it between, and then get your graph real quick. It doesn't make a difference to me which way you do it, though. It is important that you have this as your solution. All right, let's look at some of the special cases. Step 1, isolate the absolute value. That's already done. But we notice it has a negative here. Now, in the other section, we said if it was an absolute value and it equaled a negative number, there would be no solution. Why? Because a positive cannot be equal to a negative. That makes sense. But this doesn't say equals, this says less than, so you need to think it through. All of these coming out of here are positive. Are they ever going to be less than negatives? Are positive numbers less than negative numbers? Never. So what would your solution be? None. So you have to think about it. That's why I was writing this when we were doing it with the equal to signs. All right? Now what's that other case going to be? What if you have an absolute value less than a negative? Is a positive, I'm sorry, we already did less than. Let's do greater than. Is a positive greater than a negative? Always. If it's always true, does it matter what we put in here? No matter what we put in this little thing, it's going to be positive. It'll be bigger than this negative number. So we would write all reals. Meaning everything we can think of will work in this problem. So those are your three cases. Those are your three special cases. That's our step 2. If we can do that, we'll save a lot of work. Okay, number 11. We have to isolate the absolute value. So we're going to add 7. We have to do that before we can look for our special cases. Otherwise, people will start giving me no solutions in real numbers right here, and as you can see, that's not correct, because now there isn't a negative number out there. So we have it isolated. We want to set up our two equations. E minus 5 is greater than 5, or, because it's greater than, E minus 5 is less than negative 5. So make sure you do the double switch. Add 5, E is greater than 10, or E, let's see, add 5, we get a 0, less than 0. It's an OR problem, so we don't try to rewrite this, only for AND problems. For OR problems, we go straight to the graph. Let's see, I need 0 and 10. Greater than 10, less than 0. Looks just like what an OR graph should look like, so I think I probably did it correctly. All right, number 12. Two more. Number 12. Isolate the absolute value, so divide by 4. 5y is greater than or equal to 3. Does it have a solution? Or is it one of the tricks? No, because we don't have any negative over here, so we got to solve it. 5y is greater than or equal to 3, or, because it's greater than, 5y is less than or equal to negative 3. Y is greater than or equal to 3/5, or y is less than or equal to negative 3/5. Or problems, you go straight to the graph. 0, 1, negative 1. Greater than 3/5. So that would be right about here. It's greater than or equal to. And negative 3/5 would be right about here. Now if you want to, you can put negative 3/5 and 3/5. But you don't have to, because I can see that they're between the whole numbers 0 and 1. All right. Last one. Isolate the absolute value. What would you do to both sides? Divide by negative 2. Remember, we're dividing by a negative. What does that do? Switches this to less than. So let's highlight that. Switches this to less than negative 1. Wait a second. That's a negative. That's a trick. Is a positive less than a negative? Never. No solution. Don't have to do all that work. So you want to really check for those no solutions in step 2. So this is putting it all together. There's a lot to know. Lots and lots of stuff to know, so you have to be careful, and if you go through each step individually, it will be helpful. Now, as a side note, let me give you some information for your ACT. We're graphing these with closed circles and open circles. These are when we have the equal to signs, and these open circles are when we don't have the equal to signs. Well, sometimes they do it with parentheses and brackets. I have that backwards. One second here. Brackets for closed, parentheses for open. So if you have x is greater than 4, and you have to graph that, we'll put 4 right here, it would go like this. It'd be a parenthesis and then there, instead of an open circle. It's just a different way of doing it. X is less than or equal to 1. You would have a bracket. And you can see the bracket faces the way of that you're going to color. So it might be a parenthesis or a bracket either way, like that. So just so you know, on the ACT, if it's a multiple choice question, all that parenthesis and bracket mean are open and closed circle. If you'd like a practice with some of that stuff, you can use either way when you do your graphs. Open and closed circles or parentheses and brackets. It might be useful if you did parentheses and brackets so that you practice a little bit.